Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6. We present about aromatic compound.
Hi, my name is YUSRA binti FATHULRAHIM.
My name is MARSYA IMAN binti MAHADHIR.
My name is Azwa Alia NABILA binti NORAZLI.
There are two tasks to be discussed. The first task is synthesis and reaction of organic compound, and the task 2 is ilmu nakli and akli component assessment. Let's start with the task 1. The first question asks to draw the structure of toluene, which is you just draw the aromatic ring and attach methyl with any of the one carbon. The second question is asked to write a chemical equation to produce toluene from benzene. So, benzene will react with methyl chloride in the presence of aluminum chloride as a catalyst, and it will produce toluene and hydrochloric acid. The type of the reaction occurs is called electrophilic substitution. Next, fourth question is asked to state the type of mechanism involved in the formation of toluene from benzene. It is called Friedel-Crafts acylation mechanism. The next question is asked to show the reaction mechanism, including the formation of resonance structure for the uranium ion. There are 3 steps. The first step is called generation of electrophile. Methyl chloride will react with catalyst, which is aluminum chloride, and are in equilibrium with methyl cation and tetrachloroaluminium anion. The removal of chlorine from methyl chloride to form the electrophile species is called methyl cation. Step 2. The formation of uranium ion. There is benzene with one hydrogen. Nucleophilic site will attack by the electrophile methyl cation. The double bond will break forming the uranium ion, and it will do the resonance established carbon cation. Methyl will bond it with the same carbon with hydrogen. The next carbon will become positive. Electron in the aromatic ring not stay in one place. The carbon next to carbon cation didn't have enough electron, so the double bond will move to the next carbon to stabilize it. It causes the positive charge moving to the next carbon. The double bond do the same thing as the previous, and it will keep happen until the ring can bear its aromaticity. Step 3. Loss of proton. So we have the structure of uranium ion. Hydrogen ion will attack the catalyst, aluminum chloride, and then the electron in bond will be given to the ring. Finally, the ring gain by its aromaticity, which is toluene, and form hydrochloric acid and aluminum chloride. The next question to suggest a chemical test that can be used to distinguish benzene and toluene. We use the oxidation test by using potassium permanganate.
So for question 7, the question asks to write the equation and state the observation for both toluene and benzene compound. For toluene, when toluene reacts with calcium manganate, it will produce benzoic acid, carbon dioxide and water. And the observation for this reaction is purple color turns to colorless. Next, for benzene, when benzene reacts with calcium manganate, no reaction will be produced, and the observation is no change because the absence of hydrogen atom. So next question is the bromination of toluene in the presence of iron bromide produce 2 product, which is L and M. In this question, we need to write the equation of the reaction and name the compound L and M according to IUPAC name system. So the equation is toluene using the catalyst bromine and iron bromide will produce 1 bromo 2-methyl benzene and 1 bromo 4-methyl benzene. We also can name the compound L as O-bromotoluene and compound M as P-bromotoluene. Next, why the reaction give 2 different products? It is because methyl is an electron donating group that is activating group. It is ortho-para-director, so it will produce 2 different products. Next, for question 11, the question asks to draw and give IUPAC name of the product obtained if iron bromide in the reaction is replaced with light. So this is the product that will obtain when we replace iron bromide with light. It will produce benzyl bromide, or also known as bromomethylbenzene. Okay, this is the equation for the reaction. When toluene with the presence of light, it will produce benzyl bromide, and the type of reaction that occur is free radical substitution.
Now, we will move to task 2, which is inorganic component assessment. The plant that we chose is named as sweet basil. This plant contains one of the components that is related to our topic, which is methyl chemical, and it is also known as estragol. Sweet basil is made up of 70% of methyl chemical. The IUPAC name of this compound is 1-methoxy-4-prop 2-anilbenzene, and the functional group presented is benzene. Here we attach the structure of the compound. We found that the 12th verse of Surah Ar-Rahman is the related Quranic verse for this topic. A'udhu billahi minasyaitonir rajim. Wal habbu asfi war rayhan. Sadaqallahul azim. The meaning is, and the grain having chaff and fragrant flowers. We are focusing on the words fragrant flowers, which is referring to our chosen plant, sweet basil. Next, let's talk about the composition of the plant. This plant contains many components that are really useful for us. The first one is calcium with the weight of 4.6 microgram. As we all know, calcium is a nutrient that all living organisms need. Secondly, vitamin A with the weight of 6.9 microgram. Vitamin A is one of the essential vitamins that body needs for growth and development. Thirdly, lutein and zeaxanthin with the weight of 147 microgram can help us with our eyesight. Next, 81.7 microgram of beta-carotene can be found in sweet basil. It gives vivid yellow, orange and red coloring to vegetables. It is also known as a vital nutrient for our vision. Then, beta-carotene with the weight of 1.2 microgram can also be found in this plant. And the last but not the least, vitamin K with the weight of 10.8 microgram can help to make various proteins that are needed for blood clotting and bones building. Let's move to the next one. Here, we provided 3 benefits of sweet basil. The first one, reducing oxidative stress. Basil is full of antioxidants such as eugenol and limonene. These antioxidants can help to fight free radicals in the body, or else these free radicals can lead to cell damage. Do you know that sweet basil can help in reducing inflammation? Essential oils in basil such as eugenol and citronellol can help to fight inflammation in the body. These anti-inflammatory properties can help to lower the risk of inflammatory conditions such as heart disease and bowel issues. Sweet basil can help with blood sugar regulation. It may help to reduce high blood sugar levels, and it can also be helpful in treating long-term effects of high blood sugar. So now, let's get moved to the chemical reaction to produce methyl chemical. Methyl chemical belongs to the phenylpropanoid family whose members are being derived from phenylalanine. In the first reaction step, enzymes phenylalanine ammonia liase PAL catalyzes the cleavage of ammonia with formation of cinnamic acid. Starting from cinnamic acid, the C3 side chain is modified and the hydroxyl groups are introduced oxidatively into the phenyl ring, and the latter in turn being methylated in a stepwise fashion. And then it will go through reduction to produce anethol and methyl chemical.